Before we get into talking about the Pythagorean theorem and right triangles, we need to do a quick review over simplifying radicals because when we take the square root using Pythagorean theorem, we're going to have to know what to do. What can we do other than using decimals in order to deal with our square roots? And sometimes we just simplify them, kind of like when we simplify fractions. So first, let's talk about what's a perfect square. If I talk about something that is a perfect square, 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and then so on. 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. It's good to know through 15 squared just by heart. It just makes it a little bit faster when you're doing it. Now, when you do perfect squares, they're easy to take the square root of. So the square root of 25 is 5 because 5 squared is 25. So the square root of 36 is 6 because 6 squared is 36. And the square root of 100 is 10 because 10 squared is 100. And the square root of 49 is 7. So perfect squares and square roots, they come out with nice whole numbers. But what about the square root of 20? Well, the square root of 20, 20 is not a perfect square. No whole number squared is 20, so it's going to be a decimal answer. It's going to be somewhere between 16 and 25. The square root of 20 is somewhere between the square root of 16 and 25, so it's somewhere between 4 and 5 because the square root of 16 is 4, the square root of 25 is 5, so the square root of 20 is somewhere in between. It's going to be slightly closer to 16 or just 4 than it is to 5. And if you type it in on your calculator, you get 4.472 and then a whole lot of decimals. The square root of 27 is going to be somewhere between the square root of 25 and the square root of 36. Those are the closest perfect squares to 27. So it will be somewhere between 5 and 6. It'll be closer to 5 than it will be to 6 because 27 is closer to 25. If you type it in on the calculator, you get 5.196 and then a whole bunch of decimals. Now, these answers are approximate. And it's really hard because we feel like they are, when I round, we feel like they're exact. But exact means all the decimals are included. We keep them. As soon as I say, nope, this answer is 4.5, I just said the rest of these numbers aren't important. That means that this is approximately 4.5. This is approximately 5.2. Okay? Exact answers mean that we want to leave the idea of all of the decimals. We don't want to do anything. We don't have to make a decision about what we're going to round to. So in order to do that, we're going to simplify the radical. There are two ways to do it. You can use perfect squares or you can use factor trees. And I'll show you both ways. I personally prefer perfect squares. I think they're shorter, but I'll show you both ways. So using a factor tree, the square root of 24, we're just going to factor it. It becomes the square root of 2 and the square root of 12. Then that's the square root of 2 and the square root of 6. The square root of 2 and the square root of 3. Now what you're looking for is pairs because the square root of 2 times the square root of 2 is 2. Okay, we talked about that before. The square root of 2 times the square root of 2 is 2. So these two, there's a pair. I can do the square root of 2 times the square root of 2 is 2. And then I have 2 leftovers at the bottom of the branches that didn't get used. The square root of 2 times the square root of 3 is the square root of 6. So that's with factor trees. That's one way to do it. You can also do it with perfect squares. Now to do it with perfect squares, you'd go back up to this list and you'd say, okay, well 24 falls right here. And so you work your way down the list. Does 16 go into 24 with a whole number? No. 9 doesn't go into 24 with a whole number, but 4 goes into 24. So 24 can be divided by 4. So what we would do is we would split 24 into its perfect square and its leftover. So 4 times 6 is 24. Now we just simplify from there. Take the square root of anything you know the square root of and leave the rest. I know what the square root of 4 is off the top of my head. It's 2. And then I don't know what the square root of 6 is. It's a decimal. I don't want to deal with decimals, so it's the square root of 6, and you just leave it. Both ways, we got 2 square root of 6, 2 times the square root of 6. Okay, so it doesn't matter how you do it, whatever you want to do. Okay, again, like I said, I prefer perfect squares. So 27, go back up here. 27 falls right here. Work your way down the list. 25 doesn't go into 27 without decimals. 16 doesn't, but 9 does. So I break this up into the square root of 9 and the square root of 3, because 9 times 3 is 27. So I'm just splitting it into 2 pieces, or its factors. I know what the square root of 9 is. I can take that on the calculator. But the square root of 3 on the calculator is a decimal, so I'm just going to leave it all wrapped up in its nice little square root symbol instead of getting decimals. That is called leaving it exact. Okay, we are leaving our answers exact because I don't have to round. I'm not deciding that something's not important. The square root of 80, we go up here. Okay, then we just check. 80 divided by 64, divided by 49, divided by 36, divided by 25, divided by 16. 16 goes into 80, so we're going to split that into the square root of 16 and the square root of 5. Okay, the square root of 16 is a number I know. It's 4. The square root of 5 is a decimal I don't know, so I'm going to leave it alone. 4 times the square root of 5. 54, again, go back up to your list. That means you need to keep that list handy if you're going to use perfect squares. Work your way down the list until you get the biggest number, the biggest perfect square that goes into it, the square root of 9, and 9 times 6 is 54. The square root of 9 is 3. The square root of 6 is a decimal. I don't want to deal with that, so it's 3 times the square root of 6. Notice every time I have put the perfect square first. I do that so I'm being consistent. I do the same thing every time. Now, square root of 34. We go up here. 34 falls right here. 34 does not, 25 doesn't go into 34, 16 doesn't, 9 doesn't, 4 doesn't, and 1 does, but the square root of 1 is 1, so that doesn't help me any. So the square root of 34 is as simplified as it can get.